Hello and welcome to my channel. I am mensah Augustine. Please, if you are new here, can you subscribe to my channel? And if you have been watching my videos and if you're not yet subscribed, please kindly subscribe us to build the mathematics community. In this lesson, we are going to prove using the principle of mathematical induction. Please, if you have any question that you would like me to help you, just send it to my WhatsApp number +23324536079 and I'll be of help to you. Remember to like my videos, share, subscribe, and leave your comments. Now, we are to prove using the principle of mathematical induction that for all n subsets of natural numbers, n times n+1 times n+5 is a multiple of 3. Now, let's take the solution. Now, we let the given statement be Pn. That is, we write Pn as n times n+1 times n+5. And then show that the base case is 2. That is taking n equal to 1. So we find P1 to be equal to, wherever you see n, you put 1. So 1 times 1 plus 1 times 1 plus 5. That will give us 12. And 12 is a multiple of 3. Now, we come to the inductive hypothesis step. That is, we assume that pk is true for some positive integer k. Now, we put k in place of n to get k times k plus 1 times k plus 5 is a multiple of 3. If it is a multiple of 3, then it means that k times k plus 1 times k plus 5 is equal to 3 times a certain number, n, which is a subset of natural numbers. Listen. This implies that k times k plus 1 times k plus 5 is equal to 3 times a certain number, because we are saying that this is a multiple of 3. 18 is a multiple of 3. This implies that 3 times a certain number will give me 18. And here 6 equal to m. It means that this m is 6. That is exactly what we've done here. If k times k plus 1 times k plus 5 is a multiple of 3, then 3 times a certain number m, which belongs to natural numbers, will give us this. Great. Now, let us proceed. Then we are going to prove that pk plus 1 is also a multiple of 3. So wherever you see k here, you put there k plus, wherever you see n here, you put there k plus 1. So n k plus 1, n k plus 1, and you have plus 1 here, n k plus 1, and you have plus 5 here. That's very simple. Now, how do we proceed? Just look at the trick. The trick is that we should simplify pk plus 1 and get pk inside, and then replace that one by 3m. So it means that we need k. We need k plus 1 and we need k plus 5 in this expression to stand alone, so that we replace that one by 3m. So let us proceed. So here we have k plus 1 here. We shouldn't touch it. We have k plus 1 plus 5. So we can regroup this to get k plus 5. So we write this to be equal to k plus 1 times k plus 2 times k plus 5 plus 1. And then expand this. So this will give us k plus 1 times k plus 2 times k plus 5. Will give us k plus 1 times k plus 2 times k plus 5. Then k plus 1 times k plus 2 times 1 will give us k plus 1 times k plus 2. So you've seen that we've gotten k plus 1 here, multiplying k plus 5. So it has left with k. So it means that we don't need this k plus 2 here. So let us expand. And this is how we are going to do. We are going to write this one as k plus 2 times k plus 1 times k plus 5, and then expand. So k times the whole of this will give us k times k plus 1 times k plus 5, and 2 times the whole of this will give us plus 2 times k plus 1 times k plus 5. Please kindly like, share, subscribe, and leave your comments. So here we are going to get k times k plus 1 times k plus 5 plus 2 times k plus 1 times k plus 5 plus k plus 1 times k plus 2. Wow. You've seen that we have this expression here. That is exactly what we have here, and it's equal to 3m. So we write 3m, that is pk, is 2, plus we have k plus 1 here, we have k plus 1, so you can factorize it out to get k plus 1 times 2 times k plus 5 plus k plus 2. This gives us 3m plus k plus 1 times 2k plus 10 plus k plus 2. So this gives us 3m plus k plus 1 times 3k plus 12. And here 3 is a factor, so you can factorize 3 out. So this gives 3m plus k plus 1 times 3 times k plus 4. Then this gives us 3m plus 3 times k plus 1 times k plus 4. So you have 3 here, you have 3 here, so you can factorize 3 out to get 3 times m plus k plus 1 times k plus 4. Wow. Now for pk plus 1. So you have pk plus 1 is equal to 3 times this expression. So if we let this expression to be equal to, let me see, r, then we have pk pk plus 1 equal to 3r, where r is a subset of real numbers. So pk plus 1 is true whenever, pk plus 1, pk plus 1 is true whenever pk is true. That is the statement n times n plus 1 times n plus 5 is a multiple of 3. And whenever pk plus 1 is true, then pk is also true. That is what we've proved. Please kindly like, share, subscribe to my channel, and leave your comments. Bye bye.